background and did her bachelor's and master's in computer science. So I would like to welcome Shuchi. Please come, and she'll going to talk about teaching with and about AI in Twitter.
Is it working? Yeah. Can you hear me? All right. Thank you very much, Shitanshu, for the invitation, and to Samir and Sridhar and Neeldhara and everyone in the T4E and Compute teams for gathering us all here in this wonderful place at IIT Gandhinagar. It truly is a delight to be here to talk. Maybe I should call it AI for E, because it covers a lot of things, teaching about and with. Just to add a little bit to that introduction, I'm not new to working in India. Of course, I grew up here, but for about 6 years in the early noughts, I worked as a technology integration specialist and teacher educator in schools in Bangalore, did some workshops at TIS, iDiscovery. I ran an after-school robotics club in Bangalore. And most of my work in the US is funded by the National Science Foundation. You'll hear the phrase NSF come up a few times in my talk. And the work focuses primarily on curriculum, assessment, pedagogy, equity and inclusion. And so, with my background in the learning sciences, I tend to bring, principles of learning, good learning to all these design efforts. And after Bangalore was the PhD, SRI, Looking Glass Ventures is where I am now. So a quick roadmap. A good place to start is always the rationale, the why, and then we'll look at teaching with AI, and then about AI, and then a few closing thoughts. So some of what I'm going to share is shaped by experiences on 2 recent NSF-funded efforts on designing learning that I led or co-led. And I'm also going to I'm wrapping up another project which is about using generative AI in the classroom, focused on high school math teachers' experiences. That's the topic of my paper this afternoon. I'll touch on it briefly. And some of my perspectives also come from other projects and efforts that I advise, like Teach AI, which is a large global consortium supported by the World Economic Forum, as well as the Generation AI project in Finland. And I also recently authored and helped produce briefs on ethical AI research in education and AI in STEM teaching and learning. So I'm going to be bringing all of that into this talk, and also this paper that you may have read or seen that was published earlier this year at ACM's flagship CS Education Conference, SIGCSE, in Portland. All right. So as recently as 3 to 5 years ago, these were the kinds of things that would be the center of our conversations and presentations. It was all about K-12 CS education, and it's been a passion for many of us here. CS for all hashtag was the thing. And we've been making slow but healthy progress around the world. These are the headlines from just this year. But almost overnight, things changed 2 years ago, almost to the date, with the arrival of ChatGPT. Chatbots and large language models, or LLMs, have captured the imagination in a way that no one had foreseen. And AI has dominated ink and pixels in news articles for 2 years now. And I'll just show you a little bit of a taste for that. There's been a non-stop deluge of how LLMs and AI are transforming the world, and progress is happening at a dizzying pace. In fact, pioneers like Fei-Fei Li at Stanford are already moving on from large language models to what she calls large world models. And these are models that reason about things and places and interact in time and space, as opposed to just being limited to language. You'll constantly see articles that spell doom and gloom, that make you justifiably afraid and unsure what to make of this movement of AI. I don't know if you all caught this recent article of how Google Gemini, ended their conversation with a student going on this major anti-human rant, saying that you're a drain on the earth, a blight on the landscape, a waste of time and resources, please die. So clearly, there's trouble every now and then. And there's so many examples of just how pernicious AI can be, perpetuating the biases that exist in our societies in ways that were not always apparent with computing alone before AI. There's also a lot of buzz around AI in education as well as AI education, which includes AI literacy. And AI literacy not just for students, but for people in the workplace and just about everybody. Many, many headlines that reveal how teachers and students are grappling with this new reality. And some of these new developments in schools are honestly quite disturbing, with issues of cyberbullying, sexual exploitation, loss of privacy, and related mental health issues. In fact, in this context, the US Office of Civil Rights has just released what I think is a very important document, which lays out scenarios which basically involve discriminatory use of AI, and schools and entities could be held accountable. For example, if there's an English language learner and a teacher basically wrongly says, no, the AI tool is giving you an accurate grade, whereas the student is feeling discriminated against because they can't speak the language, that's something that can be investigated. If there were news of classmates being sent around and it was reported to the principal and the principal did nothing about it, people could be hauled up for that kind of thing. And if certain people, kids of certain races are being discriminated against by technologies like facial recognition, and the school does nothing about it, that can be an issue for the OCR. So even as this ongoing debate about whether AI is good or bad rages on, the truth is that AI cannot be ignored. And the reality is that these very powerful tools that are capable of amplifying human intelligence, as visionaries had imagined about 60 to 70 years ago, these are here, and here to stay, I think. And it all started with this ambitious Dartmouth summer research project on AI in 1956. I don't know if you all are aware, but they decided to bring a handful of people together to solve the problem of AI. That's why I use the phrase ambitious. And if you all don't like the phrase artificial intelligence, you should blame this gentleman, John McCarthy, who phrased that. And of course, the idea is older than even that. It's a good time to rewatch The Imitation Game and this 2-minute clip.
Oh, can they? Could machines ever think as human beings do?
Most people say not.
You're not most people.
Can you all hear?
Well, the problem is you're asking a stupid question.
I am?
Of course, machines can't think as people do. A machine is different. A person. It's they think differently. The interesting question is, just because something thinks differently from you, does that mean it's not thinking? No, we allow for humans to have such divergences from one another. You like strawberries. I hate ice skating. You cry at sad films. I am allergic to pollen. What is the point of different tastes, different preferences, if not to say that our brains work differently, that we think differently? And if we could say that about one another, then why can't we say the same thing for brains built of copper and wire, steel?
And that's this big paper you wrote. What's it called?
The Imitation Game.
Right, that's what it's about.
Would you like to play?
Play?
It's a game, a test of sorts, for determining whether something is a machine or a human being.
How do I play?
Well, there's a judge and a subject. The judge asks questions, and depending on the subject's answers, determines who he is talking with, what he is talking with, and all you have to do is ask me a question.
All right. So do you all
Okay.
know which character Benedict
Could
Cumberbatch
machines
is playing?
ever think as
Who is he playing? Who's this main person talking? Turing, yes. And of course, the Imitation Game is what famously became known as the Turing test. And this is the paper from 1950 that Alan Turing is talking about. And it's a test of whether a machine can pass off as a human in a chat exchange. And I think rightly, as people have said, that that test has finally been passed with LLMs. The study of AI over the years has actually been a study of human intelligence, the nature of human intelligence, and what it means versus machines. And one thing I do appreciate about this current AI moment is that it's forcing us all to think about what it means to be human, right? And I tend to, though, push back on glib statements like this. I would argue that a lot of AI that we use today embodies certain human values. So this broad swathe human values is not quite right. And in fact, it's the values of the West where these technologies have been created, more likely than that created these technologies. But I also want to inject some healthy skepticism into this AI hype cycle that we find ourselves in. Since those early days of AI optimism has gone through many peaks and troughs. And although, the trajectory right now is shooting upward, there may be a plateauing or even another downturn. By the way, can anybody guess what happened in these two periods that really powered the place that we are today? The 90s and then the 2000s? Is that? Y2K, no, I would say the internet. The internet, which started to put a lot of, people started to, put a lot of text and, share a lot of things. Social media was another big, inflection point where a lot of images and data put up by billions of people around the world suddenly started to power big data and machine learning. And the algorithms that these people started to, neural nets and things like that had been around since 70s and 80s. But it's just that they didn't have the computing power nor the volume of data to actually train these models. And so yeah, AI now is not the future, it's here and now. It's not monolithic. It's now an integral part of how our world works. It's not magic. It does not happen without humans. It's not always accurate, not always reproducible. There's a margin for error, especially with LLMs. It's not perfect. It has biases that can enter at all levels of the AI process. It's neither good nor evil by itself. It's how people use and create it. And so basically, with all of this as our current reality, doing nothing in the field of education is not an option. Just like access to the internet and computers were in the past, who gets to use and understand AI could fuel the next digital divide. And it is our responsibility to ensure that children are well equipped to understand the world that they live in. And computing and AI are just a big part of it now. And knowing and understanding something makes you a much better informed consumer. And education truly is the best strategy for thriving and the best inoculation against misuse. So that's the rationale, I would say. So when it comes to K-12 education, the age of AI, we're talking about two things. One is teaching with AI, which is patently about using AI as a tool in the teaching and learning process. And the other is educating people about AI. And that, of course, includes the foundational AI literacy as well as digging deeper. So, with AI. So now AI in education is not new at all. The goal of this graphic is really to underscore that AI in education has progressed in parallel with the progress of AI itself, right from the 1950s. There's a long history and evolution of this pre-generative AI in education. I think the most prominent AI and ed efforts in recent memory took off in the 80s and 90s with the cognitive tutors and intelligent tutoring systems. Carnegie Mellon is here. I don't know if Stamper is around right now, but that was ground zero for that work. Initially, it was designed on the behaviorist model of learning. Individualization was basically what was through pacing. But then, as computational tools became more sophisticated, there was increasing adaptivity with things like help and hints. And it spawned new subfields at the intersection of CS and education with conferences and journals, educational data mining, learning analytics, AI ed, etc. In fact, John Samper and I co-led a project 10 years ago on this. There was a clickstream of big data from digital environments coupled with computational analytics, which led to more adaptivity and personalization. And then, with that came increasing attention to socio-emotional factors in learning and multimodal analytics, which were learner cues besides log data. It was speech, facial recognitions, gaze, gesture. And support was not just for individual learners now, but for collaborative learning, increasing attention to support, not to replace teachers in the classroom with teacher dashboards, combining teacher knowledge with predictive analytics, and it's increasingly become human-centered with inclusive designs as focus on educational equity has increased. But all of this required adoption. It was slow. It required planning, funding, stakeholder buy-in, professional development. And in contrast, generative AI arrived. It's an arrival technology. Just like mobile phones, it came directly into the hands of students and teachers to use as they wished. It's a general purpose AI, no longer the narrow AI that the previous AI used to be. And it's already embedded in many tools that students and teachers already use. You know, Google Classroom, etc. It's already embedded in search and whatnot. So I recently co-authored a brief on AI in STEM teaching that will be released in January that examines recent NSF-funded efforts. And here's a sampling of what is happening, at least in the US, around, you know, the use of generative AI for STEM teaching. So projects like constructing, training, fine-tuning a generative AI LLM chatbot to assist teachers in developing culturally responsive curricula with a focus on an ethic of caring. This is my project using natural language prompts, having a math LLM generate technology-enhanced formative assessments that require coding at the back end, an NLP digital assistant for educators to provide assistance in tailoring lesson plans according to a teacher's goals, image generators to provide a hook to a lesson, while a classroom teacher is working with certain individuals or groups, an AI instructional bot or assistant is working with other kids in other groups, classroom groups. An NLP-based tool to give instructors feedback on dialogic instructional practices, including uptake of student contributions. This reminds me of the project Karishma talked about last night at Shiksha. You know, I think she's just started her PhD with Sridhar. Classifying students' expertise levels in scientific explanations, human-in-the-loop NLP to automatically score short answer questions, informative check-ins, generative AI and LLMs as virtual facilitators providing real-time feedback to math teachers during teacher PD. So this is just sort of a taste for things to come. These are research projects, but perhaps, you know, there'll be EdTech projects soon that will be doing these kinds of things. A little bit about my own project. It's centered on formative assessment in high school math classrooms. And the idea is that we wanted to give teachers the ability to create technology-enhanced formative assessments, which normally require coding. These are randomized, parameterized problems. They can give help and hints and solutions and whatnot, auto-gradable. And it requires, there's a webwork format that requires Perl at the back end. And so normally teachers just used, you know, a bank of problems. But imagine now, you know, that's the code in the back end, that's the problem, step by step, etc. And so now a teacher could just give an English language prompt like that and have this code generated for them. And this is with Edfinity, Looking Glass Ventures assessment platform. And this LLM tool called Alice has basically been trained on a large corpus of webwork problems. So the research we conducted with a bunch of teachers, this is the paper I'm going to talk about, so I won't spend much time here. But what I really want to share is that in in-depth interviews, it turned out that there are several factors that affect teachers' experiences with a tool like this. It depends on the teaching context. It depends on the teacher's background and attitude towards AI. Some of them really enjoyed it and some didn't really care. And it turns out that some of the ones that don't really care about using technology in the classroom anyway. They don't really like, you know, software and AI tools and such. There's a learning curve with respect to prompt engineering, whether or not they view generative AI as a thought partner, how it aligns with their teaching philosophy, what is business as usual for them, and what is this bringing to the table? What's the utility and functionality of the tool? And some teachers actually engage their own students with, you know, this whole prompting process, etc. So, you know, some teachers sort of had more fun with it. And that impacted their experience. And I share this because in essence, this encapsulates what makes LLM tools useful and successful in classrooms. These are all alignment vectors that we have to attend to if we want LLMs to, you know, work as we intend to in the classroom. And staying on the theme of assessments for a while, there's been a lot of talk about how, to assess what students have learned, giving these amazing capabilities of AI to produce essays and code and answers and everything. And these are the approaches being currently taken. It's clear to me that assessments need to be reimagined and redefined. We'll have to operate in that adapt and embrace phase. I don't think banning or evading is going to work. We know that plagiarism detectors don't really work. And, so recent guidance that's coming out is sort of pointing towards amending written assessments, making them more authentic, focusing on process rather than the final product, establishing guidelines, reassuring and supporting students, acknowledging use of generative AI in assignments, and managing suspected breaches of guidelines. So some more considerations that came out from that AI in STEM teaching brief. Can an LLM be fine-tuned or augmented or customized for a specific topic or context? How might we design tools to give to teachers the control to do that last mile of customization? What pedagogies and cognitive models of student learning are encoded in the LLM? There's no one-size-fits-all in learning. Whose language and worldviews are being privileged? How should biases be addressed? How can we promote rather than hinder culturally relevant designs? And we've seen that there's several biases in image and speech AI tools. Which model should be used for which task? LLMs have not been tested yet, and we know that not all LLMs work the same way. So, and they misinform. How can we leverage things that we know from learning theory and research? For example, learning progressions and such. How can situational awareness of the classroom be incorporated? How can we center teachers and learners and the social culture of the classroom and the communities in which learning happens? And when it comes to the holy grail of personalized learning, from a student perspective now, those were teacher-facing issues. The hope has always been that there'll be this, 2 sigma Bloom's taxonomy thing, right? Providing real-time personalized support for student learning, engaging in conversations, preparing learning materials that are customized to individual students, empowering students by offering them diverse learning opportunities, maybe giving them a say in producing their own materials, right? With these kind of creative generative AI tools now. Fostering connected, interest-driven learning across space and time. This is something that people have worked on for a long time, not quite successfully. Engage in culturally appropriate pedagogical practices, including language customization, which I think will be very important in India, especially for students from non-dominant cultures. Supporting students with disabilities and other specialized learning needs. Augmenting teacher capacity and addressing teacher shortage, especially in resource-constrained contexts. But there are potential pitfalls too. ML models could misdiagnose or misclassify learners by overlooking key factors, exacerbating existing inequities and biases from different cultural and racial and linguistic backgrounds, not be appropriately responsive to a wide range of diverse needs from diverse student populations, tracking or pigeonholing students into limiting paths. We haven't tested any of this yet with generative AI, and people are still already so excited. Learner isolation, it could corrode the social culture of the classroom, the social climate, and loss of human relationships. If students are increasingly just working and interacting with bots, what does it mean for those human relationships that education is about? In addition to this personal tutor role that I've sort of talked about, this guide from UNESCO actually talks about many roles that generative AI could play. The possibility engine, the Socratic opponent, the collaboration coach, the guide on the side, co-designer, exploratorium, study buddy, motivator, dynamic assessor. And these actually have been put together by Professor Mike Sharples at the Open University in UK, and the UNESCO guide sort of incorporated this wonderful work that he had put together. But whatever the use case or role, it's important to remember a few very key things about learning. At the core, learning is social and cultural, it's situated and contextual, and it's values driven. And there's already a huge body of research in the learning sciences on designing for learning. Many of you I know are from these kinds of programs at IIT Bombay and elsewhere, design schools, designing for learning, that take into account these characteristics. So AI systems need to take into account that literature. So an ideal AI in education, to my mind, sort of incorporates three key components: a situational awareness of the context, research on teaching and learning, and ethics and justice. And AI-powered socio-technical systems for education have to be context sensitive, supporting and adapting to the specific learning environment in which they're being used, affording relevant support. They're socially aware of learners' interests, backgrounds, all of that, culturally competent, providing cognitive scaffolding with feeding and formative feedback, supporting collaboration, serving as a collaborative agent perhaps. They should be sustainable, accessible, affordable. They should be responsible and trustworthy. I don't think there's a single system out there that captures all of this. So, we really need to collectively develop this educational AI. And, such work is typically interdisciplinary. It involves people from domains and disciplines. It involves learning scientists, computer scientists, and it also requires educators and academia to partner with edtech companies maybe to develop good educational AI that can be sustained and be more accessible, and that are built on models of good pedagogy and inclusive education. So, given this audience, I felt I couldn't end this section on AI in education with talking a little bit specifically about AI in CS education, right? So ever since the coding capabilities of ChatGPT were first revealed in 2023, early 2023, people started writing, oh, it's the end of programming, But since then, there's been a little bit of tempering of that attitude, and there's an acknowledgement, even by people at Google just recently, saying that learning to code remains relevant. But of course, there is a changing reality that we must confront, right? LLMs have become remarkably good at producing accurate code, including code for block-based programming environments. So this is an output from ChatGPT 4o that I asked it to produce for a rock, paper, scissors game in Scratch, which happens to be a very popular learning environment for K-12 CS Ed. And even though it doesn't produce visual block code, it gives all detailed instructions of what sprites need to be created, what code goes into each sprite. It gives a rationale. It basically gives things like code for determining the winner, headers like that. I work a lot on STEM integration with coding and computing, so I gave it a prompt to produce Python code for a computational model that models the gas law, pressure and temperature gas law. And it gave this very well-commented code without much back and forth. This is like the first shot thing. And it also gave me instructions on how to run it in the terminal on the Mac. And this is the model that it created. I'm not sure if it's accurate, but basically it produced code. And in response to this simple prompt there, I'll just read it for you. Create an agent-based model that models bacteria-antibiotics relationship. And it basically gave me, and this again, first shot, this is what, no revision, etc. It basically gave a model overview. It outlined model components and behaviors. It gave me the pseudocode. It gave me an explanation of each step, extensions. It also said that you would actually code this in an environment like NetLogo, which is exactly what we do in the US. A lot of these kind of agent-based modeling is done in science and social studies classrooms using an environment called NetLogo. And so, there is a certain promise I see even in the use of LLMs for teaching coding. Because if I say now comment this code, every single line it'll comment, which is like an explanation that a teacher gives, So I think reading and understanding commented code can become a pedagogy for actually teaching how to code. Code reading is anyway a useful skill that remains relevant and important when code is being written by AI. It could assist teachers in learning to code. They always feel a little, uncomfortable in the classroom and they're not 100% confident, to teach coding. And this is now a partner in the classroom. If they can punch in the code and say, just explain this to me before I teach it to the student. It can democratize computational approaches in non-CS settings. We found it to be a huge lift for science teachers to incorporate computational modeling if they don't have a background in computer science or coding, So now if this is producing the code, then they can actually introduce computational modeling and basically have this as their partner to sort of, work with them. And code generated with explanations can also inculcate AI literacy. So, I actually see some use in LLMs in the teaching of coding too, not just producing code. And in this era of prompt-driven programming, clearly there's a need to de-emphasize students producing 100% accurate code. Maggie Johnson of Google recently wrote this article on code sense, which she likens to number sense, that students, what people need is code sense. And she defines it as a conceptual understanding, of how things are related and connected. And just like, we have number sense in math, you have code sense to be successful in this era of AI-assisted programming. Now, Teach AI in their briefs describe code sense as, again, this understanding of computer programs' underlying design, processes, and system relationships, as well as the mental capacity to analyze, simulate, and predict a program's behavior. And it supports the ability to debug, optimize, and understand the broader context. And I feel that basically, this idea of teaching to code, it's sort of getting subsumed a little bit, moving down a little bit lower, and we are moving up a level of abstraction by assisting people in just going straight off to software engineering, where there's multiple, chunks of code that are being put together to produce a system. And I actually asked ChatGPT to describe this similarity between number sense and code sense, and it gave me a very comprehensive response. And all of it, I think, is on the mark. And in summary, what it says in the end, of course, it's developed through experience. So learning to code is still relevant. You have to have a foundational understanding of coding in order to have code sense. It's just that it doesn't have to be the only thing, and you can move beyond that. And it's basically, it goes beyond procedural knowledge, enabling efficient problem solving, error detection, conceptual understanding, etc. These are foundational skills that enhance overall competency and confidence in both maths as number sense and programming with code sense. So how might we develop code sense? So these are some evolving thoughts that I've had that I shared at a recent NSF workshop. Talking through code. So algorithmic explanation is going to become a key skill as well. Use computational thinking language as a teacher. Map coding concepts to what's being modeled. Because if AI is producing code, you have to have the ability to sort of look at the code and understand these kinds of things. Connect functional parts of code chunks, fix broken models. So these are some ways, for example, to develop this skill. Explain the relationships between chunks of code, scavenger hunts and clues, what instruction is doing what, how are inputs being mapped to outputs, etc. But still require an understanding of coding. And the idea of code sense is also being advocated for in these Teach AI briefs that we are creating as part of guidance on the future of CS education in the age of AI. And I'm involved in these efforts, and these briefs are prompted by questions that CS teachers have asked in the US and across the world, I think. Why is it still important to learn to program? How are CS educators teaching with and about AI? The color coding is, those first 3 have already been released. The next 2 are just about to be released, and the next 4 early in the next year. So with that, we end that first section on teaching with AI. Now quickly to go through to talking about AI. It's about a couple of things: a foundational AI literacy for everyone. And, I'm not going to go too deep. It's basically about being able to intelligently use it as a tool. And then there's a digging deeper, where you're basically understanding how it works, perhaps in a computer science context, the CS aspects of AI. And so when it comes to K-12 education, you have to address all of this: a foundational AI literacy for everybody, and then what is being done in CS classrooms to bring together data science and AI, and then AI integration into core subjects, and then maybe an elective, advanced elective. And there's a lot of focus on this central piece right now. So if you Google AI literacy, you'll get so many, responses. Every entity that's working in this space is producing their own. UNESCO also has been very active in outlining competencies for students, for teachers. And because teachers also need to be prepared, you constantly have to think about what literacy will mean for teachers, not just students. But at the core, all of these AI literacy frameworks basically address some very key factors and aspects. One is about a basic understanding of AI, what is it, etc. The ethics and human AI relationship. And then there's a little bit of the technical aspects of it, the computational thinking and literacy, how does AI work, what is the model, etc. And the data literacy piece, what is, the role of data, features, etc. And one of the first efforts to articulate what we need to be teaching came from AI for K-12.org. It was these big 5 ideas of perception, representation and reasoning, learning, natural interaction, and social impact. And they actually had more explanation in what we call the big 5 ideas poster, which has actually been translated into several languages, including Hindi, Tamil, and if you want Gujarati or Kannada or whatever, you all should get in touch with me or them, and we can have for, if you all want to share the big ideas poster with teachers around the country here. There's also not just ChatGPT is not the only AI. Everybody, if you ask what is AI, I did this in Bengaluru recently. I did a talk in the Science Gallery, and I said, what technology comes to mind when you think about AI? And almost everybody said large language models or ChatGPT. And the fact that facial recognition systems, recommendation systems on YouTube, shopping, biometrics, medical diagnoses, chess playing games, all of that, GPS, every day, those are all AI technologies, right? And there's many fun videos that explain these concepts like machine learning, etc., that you can share with students. There are also many available tools and activities that allow students to explore machine learning and build intuitions of how neural networks, etc., work. There's a very interesting tool called Teachable Machine that was first produced by Google, but there's an even deeper and more learning-focused version of it created by the Generation AI folks in Finland. And basically, you can create or build a classifier in minutes, which does image recognition, which is like, is this a plate or a mic? You show it, and then you show different plates and mics, and with a certain level of confidence, it detects. So it's a really fun thing. The next thing, I'm racing a little bit because I just realized I'm almost out of time. The other big thing is that students need to appreciate AI ethics. Because we're dealing with decision-making being relegated to a machine, AI learning experiences must involve a critical interrogation of biases embedded in AI systems that creep in at various phases of AI deployment and development. It's not just that the data that was taken initially, the sample was skewed. And in no other field is the ethical compass more relevant than in AI. And UNESCO also has an AI of ethics framework, which recommends these 10 principles that are basically, inspired by values like human rights and dignity. It all starts with that. And so how might you, have an activity in the classroom? Facial recognition is actually a very interesting topic, to bring these issues of biases. Because it's so pervasive, and because sometimes you can fool the model, or the model doesn't work very well. And so, it draws a box across your face, etc. And, it very organically leads to discussions of biometrics at airports, the surveillance state, in which ways can citizens potentially be harmed by such technologies. There are many examples. You may have heard of Joy Buolamwini's work, and this TED Talk is definitely worth listening to and sharing with your students, and also discussing things like, the implications when these recognition systems fail, and who gets harmed. And so, part of literacy and learning about AI is about probing these kinds of questions. Who is creating these technologies? What is their motivation? Who benefits from their creation? Who is harmed? Who will be prepared to create and decide future innovations? This sort of goes back to yesterday morning's keynote by Aisha. And, there's this responsible AI and tech justice guide from the K4 Foundation that has as its core components an examination of AI technology, the creation ecosystem. For example, Timnit Gebru's experience is a case study in how big tech reacts to those who come in the way of their mission. So it's a critical lens on all of this technology creation, etc., and how finally to mitigate and eliminate harm. And issues also like climate change, the catastrophic environmental damage that training these models is wreaking, the exploitation of labor in India, Kenya, for in the name of human in the loop, they're basically exploiting labor and companies in the West are making trillions of dollars from these kinds of, and we need to give students and teachers the agency to ask these questions, even as regulatory frameworks are being put in place in every country, policies. People should have a voice in you know, how we want, how countries and people want these AI tools to be used, especially in education. And for researchers planning to do AI research in classrooms, this is a guide that I helped produce. It was a team led by Tiffany Barnes. It basically brings together the IRB framework of justice, Institutional Review Board, all of you all must know about it, of justice, respect, and beneficence, and sort of combines it with the ideas of responsible AI. So do check it out. So growing prominence of the literacy around data and data science. Data literacy, as we know, is this understanding of collecting, curating, cleaning data, but now it needs to extend to this idea of data agency. So when we're teaching kids about AI, they also need to understand data well and how they can control data flows as humans, you know, whose data is being collected and hoofed up into training these models. You know, whenever we do the cookies thing or the CAPTCHA, etc., we are inadvertently training models or giving our data away. And there's also this idea of data equity, which is the shared responsibility for fair data practices that respect and promote human rights. Sort of going back to this idea of yesterday, nothing about us without us, you know. So if you're going to use our data, then we need to maybe be compensated or whatever, or don't just use it for your own gains and purposes. So there are tools, very fun, interesting games where students can understand data, how it takes, you know, there's this app called Quick Draw. I don't know if you all have played with it, Quick Draw Google, very fun activity, which, and there's a great video that accompanies it that students can learn from. So they play with it, they see how, you know, thousands of images went into training this model. Then we go to the GitHub pages and see what data was collected by Google. And people didn't even know about it, that all this data was being captured. Now, for something like Quick Draw, maybe it's innocuous, but in what situations might it not be innocuous? When might you want you to give explicit permission for your data to be collected? So these are the kinds of discussions around, you know, you're sort of embedding ethics into an understanding about AI. And so, you know, examinations of ethics should be baked in to activities like this. When it comes to teaching kids about the technical aspects of AI and how it works and the role data plays, especially in machine learning, it has to be done in conjunction with CS education, I feel. For the simple reason that there is no AI education without an understanding of computing, and there is no CS education today without engagement with AI, because a lot of tech tools don't even follow the classical programming tradition anymore, right? I mean, the machine learning model is totally different. And so AI and CS education should be seen as intertwined. So if there are ongoing CS education efforts, make sure you sort of dovetail your AI ed efforts with them. And so in the age of AI, CS isn't just mandatory, it's foundational, as is computational thinking. You know, in the past decade, CS education efforts recognize that in addition to coding and disciplinary concepts of CS, you needed to develop computational thinking skills, which basically are these problem-solving skills that transcend programming languages, and it helps learners engage and apply computing in multiple concepts, domains, situations. The idea of CT has evolved over time, from Jeanette Wing to Grover and P to Tissenbaum, Hal Abelson, etc., and then Kafai and Proctor. And I recently wrote a blog post that I think was very well received, that is more relevant than ever now, with AI producing code that students understand what it means to articulate a problem, to decompose a problem, to examine the solution, to debug, etc. And there's this wonderful video that I reference in the paper, which in the blog post, which I'm not going to go into right now because of time. But CT is also evolving, because the machine learning paradigm is so different from the traditional classical programming model. Earlier, it used to be this rule-driven, algorithmic thinking, you know, step-by-step solution. But now it's completely changed. It depends on collecting data, curating that data, training a model, and it's non-deterministic. There's a probability of, you know, you accept it at a certain probability level or accuracy confidence level. It doesn't have to be 100% accurate. and it's black boxed, it's unstructured data, etc., etc. And so we have to evolve our CT and computational thinking learning to include this in addition to the old CT, which continues to be relevant, and include data science, etc. And we also, sort of need to build on the situated and critical and justice-centered ideas and embed them in CT learning. So a couple of quick examples from my research. CS Frontiers is a project where we aim to give high schoolers, especially females, experiences on emerging topics like machine learning and AI, cybersecurity, Internet of Things, distributed computing, and all those topics that, youngsters engage in every day in their everyday life, but they never get to sort of engage with it in the classroom. And this was a multi-institutional project, a large project. We worked with several graduate students and wonderful teachers as well. And the motivation for this work was to address the huge gender disparity in computing, which is, to basically help students see CS as relevant, inviting, and accessible, socially meaningful, and exciting. And there's a large body of research in STEM Ed which shows how to engage girls in STEM, especially computing. Pedagogies such as project-based learning, collaborative learning, interaction with role models, representation, a nurturing ecosystem, relevant and meaningful projects, STEM for social good, and connection to other subjects. And we're using this environment called NetsBlocks, which is basically an extension of the SNAP block-based programming environment. And it, by adding a couple of abstractions, it really opens up the internet and data sources across the internet to students. For example, this call block, you can have data around air quality, COVID, eclipse, earthquakes, NASA, etc., and it's all real data. Even things like New York Times, Twitter, etc. And students can bring in their own data sets too. For example, as part of a data science activity, if you actually had students collect the data from a community or whatever, you can pull that in also. And so you can do very easily, you can produce visualizations like this, which are pulling in data of carbon dioxide from 1950 to 2020 and sending it to a chart drawing service, and within seconds, students have this kind of visualization. Or they can access data sets, data services like Google Maps and overlay weather data on it. For students interested in astronomy, they could have this kind of sky map and be exploring it, movie database and COVID data, because we were doing our project during COVID. So this was the Johns Hopkins database with real data. This is real data from India during those months in 2021 or 2020, I forget. So anyway, so students are basically engaging in these kinds of data practices of pre-processing data, visualizing, working with abstractions, etc. So we actually did a whole unit on bringing climate science together with data science and computer science, and building positive perceptions of students, around computing and data, because perceptions, as we all know from the learning sciences, are important in sort of the decisions students make, girls especially, on whether or not they go into STEM learning. And STEM and computing integration is very symbiotic, as is its integration with data. I'm sorry, I'm rushing through it a little bit. Climate science is, of course, a wonderful topic to engage students because they feel very vested in this idea. Youth and teens today are deeply concerned about the planet we are leaving for them. And there's a lot of available data. I'm sure in India too, maybe you would probably have data sets that you could access from the climate data around here. And what else? So we basically brought in a female paleoclimatologist who, started the whole project with research questions, brought in data science elements. NOAA is the National Oceanic Atmospheric Agency in the US. Students create data visualizations. They work with multidimensional data structures, lists, use abstractions for processing the data, tools for visualization, etc. And one of the things that we did consciously was have them engage with multidimensional data structures, but also we created these kinds of abstractions like moving average. So, and students could actually look inside the code and see how it was done. But they just use it because it's a fairly complex statistical concept for them. And in final projects, students actually worked with real data from glacier ice cores, from corals, from climate forcing data. And the final presentations, they had to explain the data archive. Understanding data and its features is a very key piece of data science, having students engage in data science. They talked through the data set and the analysis and visualizations, etc. It was a very rich experience for them, given their responses in their post surveys, etc. It really opened their eyes to what could be done with data science and computing. And once they have this background in working with the call block and with data, etc., we move on to the AI ML module, where they engage with this socially relevant AI curriculum that's focused on issues of ethics, etc. This is the breakdown, project-based, sentiment analysis, Twitter bot classification, music sentiment. They basically include discussions on bias, real-world connections. We even bring role models. We build their data literacy skills. There's a parallel dots API, which does sentiment classification. You give it any kind of text, and it gives you whether it's positive, negative, or neutral sentiment. And you could even have it classify things as hate speech or sarcasm and things like that. So students engage in this kind of activity, and then, for their final projects, they're either classifying a New York Times article and the bias in it, or the lyrics of a song, etc. And we have a ton of papers from this project that you might want to check out if you're interested. The last example, I think I'm going to skip through. It really is an example of how students work to build a rule-based classifier around classifying a Twitter bot, but we also give them the code to actually evaluate the model to see how accurate it was, how well the classifier worked. And then we go into, the decision tree building algorithm, and it's a low-code environment. We don't expect them to do all this code because it's fairly complex, but we build intuitions by giving them, chunks, decomposing the idea into how the decision tree works. So there's a plurality of pedagogies, as you can see, for teaching AI, ML, and building data skills around it. Constructionist sense-making, unplugged activities using APIs, lifting the hood, integrating movement and cultural practices, socially relevant AI apps, co-designing ML applications, ethics-focused, integration with other subjects. And that paper that I had talked about actually has citations for each one of these kinds of projects that are being done. And there's a lot of resources out there already, freely available, on ai4k12.org. They're sort of maintaining a list for elementary school, middle school, high school, in some, sort of projects such as Black Life in AI, focused on ethics and impacts of AI specifically on Blacks in the US, resources for high school. These are my 2 projects. It's all freely available. And resources for teacher learning on ISTE, etc. So closing thoughts, there are a lot of challenges and tensions. One is, of course, a very rapidly changing landscape. The technologies haven't even settled yet. Every new version of ChatGPT is so much more powerful than the previous one. So if you start thinking about building prompt engineering skills for teachers or testing for hallucinations, and the next model is so much more powerful, it's taken care of all those things. We've actually seen this happen between GPT 3.5 and where ChatGPT 4o or O, whatever, is at right now. There's a lot of misconceptions in AI in the broader discourse. So this makes the classroom teaching and learning process much more difficult. There's a tendency to anthropomorphize AI. AI is treated as a magical thing and all that, and the way it's talked about in regular discourse. A crowded curriculum. We are just about getting going with CS education, etc., and now we have this AI to, bring into our curriculum. Building teacher capacity. Perhaps this should have been the very first one or the next one after rapidly. Nothing happens without teacher prep. I think everybody here is so aware of this issue. How deep can we or should we go? This is not something we've figured out yet. What does AI for everyone mean? What does foundational literacy mean? How much do we need? We need a robust evidence base. And so we need research to sort of, and there's, we have to balance it with the pace of adoption. EdTech tools and EdTech companies are just raring to put all this stuff into classrooms without a robust evidence base. How do we sort of hold back until we know whether something works and works well and for whom and under what circumstances? And we need to contextualize AI tools and learning for local and cultural relevance, which brings me back to a very important topic here, which is contextualize AI learning. A lot of the research that I have shared, I mean, all the research that I've shared, and a lot of the R&D work is predominantly, focused in advanced economies in the West. We need to contextualize learning experiences for India. What data sets, for example, we just talked about, that data-centered experience. What data sets might be relevant to students here? What AI tools and classifier examples? These should be drawn from local contexts. What issues of ethics are more pertinent to India, for example? How can curricular experiences leverage local language and culture? And there's a crucial need for proper teacher preparation in culturally relevant AI education. And unlike Silicon Valley, education is not in the business of moving fast and breaking things. There was a blog post I authored recently where I advocated for a slower, more deliberate approach. But there are forces external to the education systems that are so powerful, that it may be hard to hold off. But I feel that a rapid deployment could engender a new kind of digital divide, where people, schools in areas that are well resourced will have thoughtful deployment, and it won't be the case where there are, poorer schools and contexts. And so we really do need to be thoughtful about the ways in which, we deploy these so that they're beneficial for all learners. And so a few closing thoughts. AI should not be a solution in search of a problem. Start with a specific problem of education or practice and see if AI can address it without causing harm. Be circumspect and attentive to unintended consequences. Push back against, you must use this AI tool, you should use it, it will be good. Ask for evidence of outcomes, or work to get that evidence, since there are researchers here. Don't use AI simply because it's cool or whatever. If pencil and paper has worked well for teaching something, stay with it, I would say. Unless AI is a proven technology and is shown to work better or makes life easier for you. Look for use cases where AI is the logical answer because it makes possible something that simply could not be done without. And there are those kinds of use cases. Think about language, etc., working with students with multiple languages as a, translation is a very powerful, technology right now. Start with building capacity amongst teachers. Amplify teacher capacity rather than replacing them. Get them to use AI for productivity tasks, maybe, as and when it makes sense, so that they become familiar with these tools and then they can take them into classrooms. Put it in the hands of adults first, I feel. Don't bring LLMs for kids to use without robust guardrails in place. Be very deliberate about how to mitigate risks, especially amongst already marginalized students. Ensure that students use LLMs that have been fine-tuned and tested for the context and are specific to the context even within India. Remember, foundational models have really been created with data dominated from, Western English-speaking societies on the internet. And as technologists, it's very tempting for us to want to make students and teachers work with this shiny new thing, but educate them about it so that they're informed customers and consumers. And with that, I'll end this keynote. Thank you.
Thank you. Thanks, Shuchi, for the wonderful, power-packed lot of knowledge in your presentation. We are already getting requests for sharing the PPT. So
I think it's recorded too. Right?
yes, it's also recorded, and you can refer to the YouTube video. We will have maybe a couple of questions, one or two. Yes, please.
Hi, I'm Shraddha Bhutkunde from ISIGCSE Pune. I work as a teacher developer, and yesterday I got the opportunity to present a paper integrating computational thinking and scientific inquiry. It's something on the lines that you had mentioned about NetLogo agent-based models. So I worked with Sugat to bring that in India. 5 years back, we had put that work together. Going forward, inspired from your talk, I'm going to incorporate some of the ethical AI which has been researched into classroom implementation. But there's something that I had been talking about. It's also inspired from one of the images that you had put in your article, which is the evolving definition of computational thinking. So I got to use that yesterday in the presentation. So thank you for that. But what I focused on is contextualizing it in the context of maths and science, because I work as a teacher developer for high school science and mathematics teachers.
Yes.
So do you think that you focused about that, at how it can be relevant in climate and other studies, and contextualizing would be nice? But there is something that I usually try with pedagogies, that is to first put teachers in student cap, make them understand how they would feel at the student end, and then only go about this cascading model where they go on, train other teachers, and then bring it to classroom. Do you think something like that can also be done for CS and AI integrated LLMs that we do, where the teacher get to first experience it as a student, and will that be effective? What is your take on it?
Oh yeah. No, that's exactly how AI education for teacher professional development is progressing right now. We treat AI with teachers as, students and teach them, but that is mainly in the context of technical aspects, right? Which they may need more help with. But things like, using AI and understanding what generative AI can do, that they bring a lot to the table too, because it's a technology that they may have already started using, may have started seeing for. So I feel in teacher professional development, it's always great to sort of meet somewhere where you're valuing what the teachers bring to the table. But in aspects where things are very technical, yes, you sort of have to work with them and give them a sense for what it feels like to be a student, to learn. But I also want to point out this aspect of how AI itself can be a sort of buddy for them in the classroom. So attending to that aspect, I think maybe, and researching how that works might be very relevant, because there's a lot of information that we as teacher PD providers are providing them, that also a chat GPT kind of tool may have the wherewithal, and maybe a fine-tuned one that has sort of your pedagogy, etc., uploaded. You can sort of contextualize. Even with the LLMs today, you can upload a PDF and sort of say, respond to things with this as your context, in addition to whatever else you want to add. And so that can become a very nice tool as well. So there's a lot of possibility in teacher PD now that we could explore.
One more, maybe.
Hi, I'm Ram from IIT Bombay. My question is about the misinformation that is generated by AI models. So on one hand, they have this tendency to hallucinate. But on the other hand, they have this authoritative tone and a very polished output. So students might trust them a lot. And the signs which are usually found in garden variety misinformation found on Facebook or WhatsApp might be missing from the output generated by GenAI LLMs. So what are some ways we can help students to deal with the misinformation created by LLMs?
Yeah, I think the best way is to show them good examples. Basically have them, show them how, there are so many examples out there. Even today, if you sort of ask it a question and ask it for citations, invariably it's cooking up citations. You basically, by yourself, you go to Google Scholar, you find, so building in those kind of, abilities in students to actually see, make it clear to them, or it could be in the context that, a research thing may not be so relevant to them, but in the context of the things that they enjoy doing, showing them examples of how, even though to not be fooled by the polished output. And so these are the AI literacy activities that you need to be doing when you talk about, AI. And again, this is evolving. Different models hallucinate differently. It is a problem that's sort of, reducing to some extent, so it's becoming harder to sort of catch. Many responses, most responses that I have seen in the last few days, for example, while working, have not had any kind of hallucination. But there are some, viral prompts that go around how it responds to a math problem, etc. It's so confident in its absolutely wrong answer. So I think just giving students those experiences, it's actually a good exercise to do, to say that if you just copy paste blindly, this is what's going to cost you your marks, because you're going to be, you'll suffer if you just copy paste blindly. And so it sort of works in that sense too.
Okay, so thanks for the questions. We have immediately a very relevant panel to the questions that you have just asked. So maybe before moving to that, I would request to thank, I would thank you, Shuchi, told by the LOCs to give this.
Okay. Adu Panchang Pateli. Thank you. Thank you. Thanks so much. Yeah.
Now I would like to invite our panelists for the next panel session. Professor Ram, Dr. Aditya Johari, and Shuchi, you